Okay, hello everyone, welcome back. So before we talk about deep learning, I'd like to prepare a section on machine learning basics for you first. So in this section, we will provide you with some basic information about machine learning background, the problems, the settings, as well as the models to be used in machine learning. So what is the relationship between machine learning and deep learning? Generally, we can see deep learning as a special type of learning problems and models covered inside machine learning. So we want to introduce the machine learning basics for you, this general learning problem settings for you first, and then we will talk about deep learning in the following section instead. Okay, so first of all, what is machine learning? So normally the human beings can learn from the past experiences, right? So will be the computer or will be the machines. The machine and computer can also learn from the historical data, which represents the past experiences of a domain. So the main objective of machine learning is to learn a function mapping from the historical data. It can be used to predict the values of a discrete class label, continuous value, or class indicators of data instances. Depending on what we are predicting here, we can have different tasks defined in machine learning. If we are predicting the discrete class labels, then we can define the corresponding machine learning task to be the supervised classification task, because we are predicting a class label, right? And if we are predicting the continuous numbers, if so, then we can define the corresponding task to be the supervised regression task. If we are inferring the cluster indicators of data instances, we don't require any labels or any value to be predicted. We just want to partition the data instances into different clusters and get the cluster indicators for each instance. If so, then we can define the corresponding machine learning task to be the unsupervised clustering task, respectively. So depending on what we are predicting, we can have different tasks, in machine learning. And then how machine learning works. Normally, machine learning relies on the data, right? So from the given input data, the data can be very diverse. We can have the images as the inputs. We can have the text as the inputs. We can also have the graph as the inputs. Given the input data, we can do some feature engineering, right? We can do some feature engineering or feature extraction. So depending on some domain knowledge, given the input data, we can extract some features from the input data, right? Now, from the image, we can extract some features like the eyes, the color of the feather, and from text, we can extract some keywords. From graph data, we can extract some nodes, some connection patterns among the nodes, right? So generally, via the feature engineering, from the input data, we can extract some features. In this way, this dog image will be represented as a vector in the feature space. So in other words, via the feature engineering and the feature extraction, for each input data, we can extract some features and can further represent the data as a vector in the feature space, right? And based on the vector representation of the instances in the feature space, we can further define a mapping or a machine learning model. Machine learning model is a mapping. It maps the instances from the feature space into a label space, because we want to predict the labels or predict some outputs of the inputs, right? So we want to build a mapping to project the instances from the feature space based on the features into their corresponding outputs, like the labels, right? So the model is defined as a mapping or a function. And based on the representation or based on the location of the data instances in the label space, we can further interpret the results, right? For example, if this dog image is lying in this region, we can recognize this is the face of a dog, right? And we can also transform this text input into a syntax tree as well. We want to get these hierarchical structures of the words inside this paragraph, right? Similarly for the graphs, given the graph inputs via the models, we can also predict the preference of the users towards some products, do the recommendations, right? So this is a way for machine learning task. So given the input data, we do the feature extraction to transform the data into a vector in the feature space. And we can define a mapping as a model to transform or to map the data instances from the feature space to the output space. And we can further interpret the output results to get the labels or to get the path tree or recommendation results, right?